So we're going to learn how to sketch parabolas, and first note, we need to know what a parabola looks like, and they all have the same shape. They're all smooth, they're all quite flat at the bottom, they're symmetric, and we'll come back to that, and they don't curve in or curve out. And the easiest way to plot them is to work with these 5 points. The two x-intercepts, the y-intercept, so that's basically when x and y are 0, the mirror of the y-intercept using symmetry, and the turning point. So we start with the x-intercepts. When we're writing an equation, we take the intercept and that gives us the equation. Well, we're going to reverse the process and from the equation plot the intercepts. So here's an example. Our graph is y equals x minus 1, x plus 3. Well, minus 1 tells us that one of the intercepts is at positive 1, and plus 3 tells us that one of the intercepts is at minus 3. So those 2 points come almost for free. Next, we take our x equals 0, and this is the line, the y-intercept, and when x is 0, we stick it into our equation, stick it in our calculator in exactly that form, and we get that it's at minus 3, so we can plot it at minus 3. Because all parabolas are symmetric, then there must be a mirror line that runs between the two intercepts, halfway between these two intercepts. So there's a mirror line running at x equals minus 1. We can use that mirror line to now reflect the value that we've just plotted on the x-intercept, y-intercept rather, and here it is there. So that's just the mirror value of that. Finally, we can take the turning point, which is x is minus 1. It's on this line because the turning point has to be in the middle, and we plot x is minus 1 in our formula, exactly replacing x with minus 1 and typing it in like that, and we get minus 4, which we plot. So now we have 5 points, and we're going to link those up. If we draw a little bit of a straight line between them, we see our basic overall shape, but we don't use it with straight lines, we draw a nice curve. Notice the rounded base. Alright, so that's how we do it. Sometimes one of the points of my 5 suggested points will repeat. That doesn't matter, we just carry on as we did before. So here we have a parabola x plus 4 that we wish to sketch. So we plot first of all our x-intercepts. Well, they're at 0 and minus 4, we can tell straight away. So there's our intercepts. Now when we come to plot our y-intercept, it's already been found because the line on the y-intercept has already been found, so we'll just move on. Here's our mirror line halfway between the two intercepts. So our turning point is now at x is minus 2, and we put minus 2 into our formula, and we get that the turning point is at minus 4. So far so good. We could sketch it from these 3 points if we wanted to. Sometimes students don't like the fact that there's too few things to be going on with, so they'll actually plot an extra point. We could put x as minus 1 into our formula and find that it gives us that point there, and then using symmetry we can then plot it across the other side, and now we have 5 points which we can connect up with our nice smooth parabola. One more time. From our intercepts, the formula, then our y-intercept, when x is equal to 0 is put it in to the formula, our mirror line, and we reflect across. This time our mirror line is on 2.5, but that doesn't make any difference. We still carry on the method just as before. We stick 2.5 into our equation, and we get that our turning point is at minus 2.25. Now at this point we've got 5 points and we could sketch our parabola. We don't need to find any others. Sometimes students will, but they don't need to. We can just go straight ahead and sketch from there. So these are the parabolas. The shape, smooth, flat at the bottom, symmetric, and doesn't curve in and out. I'll just discuss briefly what this means. Firstly, flat at the bottom is a problem because students tend to make them far too pointed. So we don't want this pointedness. If you're getting a triangular shape, then you've done it wrong. It doesn't curve back in, and you should never see an inflection where the line curves back in as it's going to the top. And doesn't get steeper, so we don't see a kick out either. It's just a nice steep curve. One of the things that we should be aware of after we've plotted these points is that we don't actually need to plot any points, and we don't need to plot the top of these graphs. They're not going to mark you from them. They're going to mark you from the intercepts and the turning point, so any other point is unnecessary. So we just need to plot those points and then indicate to the marker that it's going to carry on for infinity. Any other points you draw aren't strictly necessary.